like to see on the board.
Can we do another problem like the last two?
The last, ooh,
Yeah.
we look at the last one, it's gonna take a lot of time.
Math lab.
Okay, I did the second to last one, so if you'd like, we can take a look at this last one. How's that?
It's the same, you just change that little, in part C, you just change that little before the 5/4K. But anyway, this is gonna be the same.
Let me grab a similar problem.
The 5/4 to the K.
All right, let's take a look at this. I'm gonna have to get to the page that has that on it, and remember it myself. Okay. Consider the following convergent series, then complete parts A through D below. We have the sum of 1/3 to the K. Use an integral to find an upper bound for the remainder in terms of n. The upper bound for the remainder is. So, we have this. The lower bound, L sub n, equals S sub n plus the integral from n plus 1 to infinity of f of x dx less than k is less than s of n plus, now this integral starts at n, which this is u sub n. Did I get that all correct? So this problem, part A here, part A says, use an integral to find an upper bound for the remainder in terms of n. So u sub n is the upper bound. Maybe we ought to do this. Upper bound for the remainder in terms of.
I have it in my notes. It's the same as 13.
I know it's the same. I gotta remember how to set this up.
I got you.
Using an upper bound. Okay, so let's see, we need to do this integral from, does the answer start with s of n, those of you that got it done? Do we do s of n plus the integral that we get when we work that out? Anybody got it?
No, it's just the integral. No,
Did they just want the integral?
yeah.
Okay. All right, let's do this integral here for the upper bound. So it's going to be the integral from n to infinity of 1/3 to the x dx, like this, which we will write as 3, oh, that's an x, not a k. 3 to the negative x dx. And I'll do the u substitution here, so we'll let u equal negative x du du will equal -1 dx. So we need a -1 in there. And counter it with a -1 on the outside. And so we have -1 times the integral, I'll leave off the bounds, 3 to the u du, which is -1 times ln, no, sorry, times 3 to the u over ln 3. Now we'll put it back in terms of x and put the bounds back on. Be -3 to the -x over ln 3 from n to infinity.
The upper bound?
So limit as b goes to infinity of this. B on top.
Is it positive? Positive 3?
We got the negative on the outside that comes down. Is it supposed to be positive?
But there's 2 negatives though. Oh, wait.
So this negative is part of the du, and this negative keeps coming down.
Okay.
Let me see what happens.
Yeah.
All right, so now, I'm running out of space up here, but we'll plug in the bounds. Limit as b goes to infinity of -3 to the -b over ln 3 minus -3
It becomes positive, right?
to the -n over ln 3.
Perfect.
That exponent is negative, which moves this to the denominator. As this goes to infinity, that goes to 0. And now we have 2 negatives here, which makes it positive. And this is 3 to the negative n, so I'm going to write this as 1 over 3 to the positive n, ln 3. So we get 1 over 3 to the n, ln 3. Is that all right? Now you're saying that's all they want in there? Hopefully they don't have a mistake. Put that in.
That should work.
That should work?
Yeah, just the example wrote it differently, but it's the same value. It just had that 3 to the -n on top. Perfect. Okay.
Okay.